Let's discuss about autoencoder and variational autoencoder. So autoencoder basically consists of two parts, encoder and decoder part. Encoder, the input is our data X, so it can be image or text, whatever. Usually the input is image. And then encoder make an output which is latent variable G from a given X. And the decoder, the input is latent variable G and the output is X hat, and the loss function or our objective function for this variation autoencoder is usually the distance between X hat and X. So we want to make some network structure or network architecture so that we can keep the information of X even if the middle part here narrow compared to the input and output data size. So the main objective of variation autoencoder is it's kind of abstraction or compression. So we usually decrease the dimension of your data size. So usually the dimension of latent variable Z is smaller than the dimension of input or output. So this is very useful pre-training technique, kind of. So from unlabeled many image data, we can train the variation autoencoder, and we can bring the autoencoder to other tasks. So this is kind of pre-trained net trained by unlabeled many images using the autoencoder concept. And then we can bring the pre-trained encoder to some other classification task with small size of data set. And we can use some transfer learning concept. So basically here we have a new input x prime. Since encoder already trained by autoencoder, the encoder will give you smaller dimension latent variable z. And since the z has smaller dimension than the input dimension, it is more easy to deal with. So we can more easily build a classifier. We can more easily train the classifier using the latent variable z. Okay, so the autoencoder is very useful concept for this transform learning or some semi-supervised learning, self-supervised learning concept is kind of. But the autoencoder has some limitations. Let's go back to the example what I explained in the previous video clip, where we want to draw this line in 2D space, which generated from 1D signal in between 0 and 1, or from some normal distribution on a real line. So we basically want to build a function, mapping function f, so that from 0 to 1 random variable we can make a full pass of the line signal on 2D space. Okay, then we can say this is very nice generative model for this line signal. So we can randomly generate any point on this line from the latent variable, 1D latent variable, if we know the mapping function f. Here the autoencoder is kind of one nice approach, one good try to find out the mapping function f from many unlabeled data. So here, this 2D space is the data space. Data is usually located in very large, high-dimensional space, and we basically start from very low-dimensional latent space. So autoencoder basically find a very nice encoder mapping from the data space to latent space, and decoder mapping from latent space to the data space. But since there's no restriction on the latent space, we just mapping from end to end, x to x hat, and just measure the distance between x hat and x. So the autoencoder learned pointwise mapping. Just learn how to map this data to one particular latent variable, learn this one particular data to one particular latent variable, and so on. So if we have let's say 5 data point, we just mapping this data and one particular latent point without any constraint. Okay. And then, okay, this is good to compress your information to very low dimensional space. But one big issue for generating or reconstruct all the 1D line signal here is we don't know what will happen on the latent space here, 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 here. We have no idea what will happen here, and we have no idea which latent value will produce this area, this area, this area, this area, and so on. So usually when you use autoencoder as some kind of generative model, so you bring the pre-trained decoder here, and randomly generate latent variable z using uniform distribution or normal distribution. The output here usually just noise, because the autoencoder just abstract or compress your information on some small dimensional, low dimensional space without any constraint. Each abstracted value in the latent space or compressed vector in the latent space is just isolated, and in between two latent vector comes from some data point. There is no clue. We cannot say anything on this kind of area.